Okay, so in this one it says 90% of working adults in USA drive a car. 20% in the USA who are working adults are surveyed. We want to go ahead and answer some binomial probability questions. So A, we want to know what the expected value is for the experiment. Well, before we get to that, let's go ahead and figure out what all of the pieces are for this binomial experiment. So we want to identify what a trial is. So a trial is, the answer to one of the 20 people that we have surveyed. So a trial would be asking each person if he or she drives. N is the number of trials, and the number of trials, we're going to survey 20 people. So N is equal to 20. P is the probability of a success, and so a success in this case is that they drive. So the probability that any one person drives is 0.9, which means that Q, the probability that they don't drive, would be 0.1. Okay, so there's the pieces that we need. To figure out the expected value, we have 20 people. And of those 20 people, we're expecting that 90% drive. So the expected value is N times P, which would be 20 times 0.9, or 18 people. So our expected value is that 18 out of the 20 drive. Okay, part B, let's answer a probability question. What is the probability that exactly 18 of these 20 people drive? I'm going to go ahead and set this up in a binomial formula, and once I do that, I'm going to use my calculator's binomial feature to solve it. So to figure out that we've got exactly 18 that drive, that probability, we're going to use this probability formula. We have a combination first. Out of the 20, we need to choose 18 of the 20 to be our drivers. So 20 choose 18 times. If 18 are the drivers, that means to be a driver, there's a 0.9 chance of that happening. So that's the probability of a success, but we're going to have 18 of those. So 0.9 to the 18. And then the other two would be that 10% chance. So 0.1 to the second. So when you're figuring out your formula here, you're going to have 18 wins, successes, in this case it's driving a car, and your probability of driving a car should be to the 18. And over here should be a failure. So we don't drive a car, there's 2 of those, and that has a 0.1 chance of happening. Now I could type this all into my calculator and come up with the answer just like this, or I could go to my calculator and use the binomial probability distribution. So it's like binomial, I think it's just that, PDF. So I can use that feature of my calculator. I'm going to go ahead and use that feature of my calculator. You're going to find it in the distribution menu. So I'm going to turn this on and clear what I've got. The distribution menu is right here on the vars key. I've got to hit second. So second, distribution. I'm going to arrow up to find this, but you could arrow down if you wanted. And I want binomial Pdf. This is if you're doing exactly a certain number. In this case, we're doing exactly 18. So binomial Pdf. And on this version of the calculator, it prompts me for the different inputs. Once I hit paste, you'll see what it looks like on the other version of the calculator. Okay, but for my version, how many trials? Well, we're surveying 20 people, so there's 20 trials. P is the probability of a success for driving, which is 0.9. X is the number of successes, and we were wondering the probability that 18 drove. So I put an 18 there, and then I hit paste. But look, it puts this right here. So if you have the other version of the calculator, you're going to choose that binomial PDF. Let me give myself a little more room. Binomial PDF, just like we did. I don't remember what the abbreviations are. And then inside the parentheses, which are actually right here, inside the parentheses, you're going to put the number of trials first, followed by P, followed by the number of successes. So our binomial PDF shows up as 20, 0.9, 18. And I go ahead and just hit enter, and I end up with this probability. So the probability that 18 drive, where's my question right here, is approximately 0.2852, or about 28.52%. Okay, so that's the binomial PDF. Let's do another one that involves the CDF. So part C, let's find the probability that at least 18 drive. Okay, a couple things I could do. I could do the probability of 18 plus the probability of 19 plus the probability of 20, which would be, oops, you can't see that, which would be a little bit of work. I could use for this, because I'd have to do a binomial PDF for this one, or the formula, a binomial PDF for that one, and a binomial PDF for the 20, and add them all together. So I could do that, but there's a couple of shortcuts that you can take with your calculator. Let me give myself a little more paper, and we'll go ahead and do the at least. Okay, here is version 1. So version 1 to solve the probability of at least 18, which is 18, 19, or 20. So we're going to go ahead and put this in to our calculator using binomial. So binomial, we're going to do the PDF version this time. Okay, on my calculator, here's what it looks like. So I'm going to clear this. Second distribution, binomial, I'm going to arrow up. PDF is the first one. 20, 19, X value, instead of putting in 18, I'm going to put in a set of values. Okay, so believe me, this is worth a trick. Second of parentheses is a set bracket, so I'm going to go ahead and grab the set bracket. And I don't want just one X value, I want 3. 18, comma is right above the 7, so 18, comma, 19, comma, 20, and then find that closed set bracket on the other parentheses. And then we're ready to go ahead and paste. And then enter. And you'll notice that when we do this with the home screen version, so if your calculator puts binomial PDF in the home screen, you're going to put the number of trials, the probability of a success, and then you'll use set brackets just like we did, and do 18, 19, 20. So it's the same amount of keystrokes. But watch what happens when I hit enter. I hit enter and it gives me a set. It gives me a set. This first one is the probability of 18. The next one's the probability of 19. And if you arrow over, there's a probability of 20. Well, that's not what I wanted. I wanted the sum. So I'm going to go ahead and add those up. So in order to add those up, I'm going to go to my list menu, which is right here. So second list. I'm going to arrow over to, I think it's under math. So arrow over to math, right, because it's a sum. And I'm going to find sum. So I went to my list menu, because what I have is a list of data. Arrowed over to the math submenu, and then I'm choosing sum. Enter. Sum of what? If you just arrow up right here, I'm just using my arrow up button. Hit enter, it grabs the set from the last problem. Oh, didn't it do that? Grabs the set from the last problem. Nope, it won't do that. So instead, I'm going to use this answer button here at the bottom, and I'm going to go second answer. And that answer was the set. So parentheses, and there's the sum of those probabilities. So 0.6769. 69. Okay, that was version 1. So here comes version 2. With version 2, I'm going to use the binomial CDF. Binomial C for cumulative DF. And this one adds the probabilities for 0 to x, whatever you're using. So if I use the binomial CDF, and I do binomial CDF 20, 0.9, 20 minus binomial CDF 20, 0.9, 0.18 here's what I'm asking the calculator to do. I'm asking the calculator to do, this is the sum of probabilities for 0 to 20 minus the sum of the probabilities for 0 to 18. Okay, if you think about what I'm doing, oh, let's see. I want to include 18, don't I? Let me put 17 here. 17, because watch what I'm doing. Because as I do binomial CDF, it adds up for me, which is great, all of the probabilities, but starting at 0. So this one is P of 0, 1, 2, all the way up to 20. I don't want all of those. I don't want any of these. I just want the ones at the end, 18 through 20. Okay, those are the ones I want to keep. So if I subtract all of the ones at the beginning, this is going to be the probability of 1, 2, all the way up to, that's why I changed that to 17, all the way up to 17. I really am subtracting out all of these guys, and I'm just left with the 18 through 20 at the end. So 18, 19, and 20. Plus the keystrokes are way simpler. So we take all the way up to 20, and then we subtract up to what we don't want. So I subtract up to 17. Okay, it might be worth watching this a second time to see how this gets inputted. Okay, so I want to go to my distribution menu, up to binomial CDF, cumulative for add, and I've got 20 trials, 0.9, and I want all 20 this time, up to all 20, paste, minus the ones I don't want. So I'm going to go second, distribution, CDF, cumulative, 20.9, but I want to just subtract the ones up to 17, so I'm leaving 18, 19, and 20. Paste, enter. Yay, look, I got the same exact answer that I got before with a much quicker method, 6, 7, 6, 9, or 67.7% roughly.